Welcome to Math with Professor V. Here's your latest integral of the day. We have an indefinite integral of the square root of x times e raised to the square root of x dx. If you want to take a try on your own, I'll just give you a hint. You need to make a substitution first and then use another integration technique. So on that note, when I make the substitution, I'm going to use t instead of u because the integration technique that's going to follow is integration by parts. And why do I have that feeling? Well, I've done an integral before, just in my life, that was x times e to the x dx. And hopefully when you were first learning integration by parts, you studied something like this. Because the exponent's not squared, u sub wouldn't work, and that's why we use by parts. And this is super similar because see how the exponent is rad x, and that's also what's being multiplied out here? So I'm getting this feeling like, ooh, by parts is coming next. So on that note, let's make a substitution. I'm going to let t equal the square root of x. And then what I like to do, don't differentiate both sides just yet. Square both sides first. So t squared is x. And then now when you differentiate, it's just so much more relaxing. 2t dt equals dx. Beautiful. So let's rewrite this integral now, all in terms of t. I have integral. Remember, rad x is now t. So that's t times e to the t. Very good. And then instead of dx, I have all of this loveliness. 2t dt. 2t dt. Great. Now let's rewrite this integrand because I have t and another 2t. So this is 2t squared e to the t dt. And hopefully you've done enough integration by parts that you recognize, yep, that's the technique to use here. Since I have 2t squared, I know it's going to take a couple rounds of integration by parts. And whenever that's the case, I prefer just to jump straight to the tabular method. So what you do, instead of choosing u and dv, you have one column where you're just going to differentiate and another column that you're going to integrate or anti-differentiate. So normally, whatever u was going to be, had you done integration by parts, you differentiate that term, and then whatever dv was going to be, you don't have to keep the differential dt with you. So e to the t, you keep integrating over here, okay? So you start with 2t squared, the column on the left, and you keep taking the derivative till you get a 0. So 4t, 4, 0. So I'm done. And then I'm going to integrate the same number of times, so just e to the t all the way down. How lovely. And then I need to take products on the diagonal, always from left down to the right. So that diagonal product, that diagonal product, that diagonal product. The first product, you don't change the sign. The next one, you add an extra negative, so on and so forth. It alternates. If you've never seen tabular integration by parts before, I have a video explaining the process, and it's great for these scenarios, especially polynomial with exponential function. Okay, so that's it. So now I'm going to write all the terms out. We're going to have 2t squared e to the t. So that's this product right here. The next one I'm going to add a negative, so minus 4t e to the t plus, and then the last diagonal product, can you spot it? It's right here, 4e to the t plus c. And no, we're not done. Remember, t was rad x. So this is 2 times rad x squared e to the rad x minus 4 rad x e to the rad x plus 4e to the rad x plus c. And then we can clean up just a wee bit more. I can write this as 2x e to the rad x minus 4 rad x e to the rad x plus 4e to the rad x plus c. I think it's totally fine if you want to stop here. You also might be inclined to factor out 2e to the rad x, since all terms have that in common. So let me go ahead and do that. So then I'd be left with x minus 2 rad x plus 2 plus c, which is very nice looking as well. So take your pick. That concludes the integral of the day for this lovely Monday. I hope you all have a great week. Started off on the right foot. Give the video a thumbs up. Subscribe if you haven't already. Let me know what your favorite part of the video is. And do you use tabular integration by parts as opposed to just the standard setup when you have multiple rounds? I do. I resisted for many years, believe it or not. I don't know why, but once I embraced it, it was just, there's no looking back. You know what I mean? So subscribe if you haven't already. Also follow me on Instagram, TikTok, and Twitter, Math with Professor V. Love you all. I'll be back sooner than later. Bye.